Exactly. All right. This is Protastructure environment. This is Protastructure 2021. Like we have Protastructure 2018. There are some other versions earlier than 2018, but I think 2018 is actually the most popular one. And then we now have 2021, which is actually great. The software is very, very great. This is the first thing you see on the interface. If I click on new project, for example, you can see we have different code of practice. We have for Brazil, we have Hong Kong, Indonesia, Ireland, and Malaysia, and all of that. Now, if you come down here, I don't know about South Africa, but in Nigeria, we use British code. We use BS8110. Some are now using the Euro code, but I think BS8110 is more popular. I hope you can see my mouse, I guess. Okay, good. So I learned that South Africa, you have your own code of practice too. All right. So I'll click on BS8110. Sorry. So once you click on it, you have to type the name of the project. Let's call this a new project. So you cannot space here under this project code. You have to use either a dash, any symbol. You can use a dash, you can use underscore. So you can see I used underscore project, new project. So I'll click on OK. So by the end of today's training, I'm going to send you a pre-recorded videos that I have recorded already. So those videos will also help you just whenever you are stuck at any level on your design. So here you can import a drawing. You can see here we have building set out, modeling, loading, review, analysis, design, reports, BIM, display, view, and then we have the help. So under the building set out, you can see what we have. We have recent project. If you have projects that you have done in the time past, you can see these are all the recent projects that I have done. You can see being displayed here. You can save as closed projects. Match building, margin building is bringing up to 2 or more numbers of building in one window. Okay, just like what you did in the ArchiCAD project you just displayed. You can see you have up to like 2 buildings in one window. So you can as well do that in your Protastructure. You can link model your model. You can link 2 different models or many, as more as you can link with it. Are you there? No. I'm using my phone as a mic. No. I'm using my phone. Yeah. Maybe it's because I'm too close to the screen. I'll shift back a little. Okay. This is DXF imports, where you can import your DXF file. Okay, it recognizes DXF file. DXF can come in is a file, a format which is recognized by AutoCAD. DXF, you can save your file as DXF in your AutoCAD environment, and AutoCAD also recognizes that format. So if you have your design already in DXF format, so all you need to do is just to import that file. So I think we are going to focus more on how to import your drawing from your AutoCAD environment. If you have your design, all you need to do is just to import it once you have done with your general arrangement. Your general arrangement is actually your structural layout. So let me check for a drawing which I have done already. So I'll click on external reference drawings. So if I click on this, I'll click on add. Let me look for where I have a DXF file. Okay, I think this is one. So I'll click on open. So it has displayed here. I'll check on this. Now you can see below here we have this drawing. The advantage of this is that you can actually play around with this. You can import another. Let's assume I'm not satisfied with that. Let me try out another design. Key. So this is the latest one I want to. So if I check on this, let's see what we have on the background. No. I think something is wrong with that drawing. So I'll uncheck these. Okay, let me delete one of this. I'll remove this, and I'll also remove this. Okay, let me go on desktop. DXF. Okay, fine. I have some drawings here. Okay, let's work with this. I'll click on OK. So the file has been imported, but you can see from this design here, there are no columns that are attached to this. The reason is because from the drawing, I did not place my columns as polylines. So I'm going to show you a perfect sample of how your AutoCAD drawing should look like from your AutoCAD environment. But as it is here, I can still work with this, but I have to manually place the columns in their positions. But let me show you an example of a drawing. AutoCAD file. Auto file. Let's check this. I hope you have AutoCAD on your system. Okay. I want you to see something here. You can see this is AutoCAD environment. This is my drawing. If I click on this grid line, you discover that this grid line is on layer that I named grid. Okay, can you hear me? I said this line, this grid line. Did you get that? You're not seeing the screen? Okay, it's not clear. No, my cursor is moving. Is it moving now? It is moving from my end. I don't know. It could be network or something. My cursor is moving. What I'm seeing here is your screen sharing is paused. Okay, it is your own that is paused, not mine. Okay. But can you see what I'm doing? I'm zooming in and out. Are you now seeing my screen? Is it now moving? It should be network then. Okay. These are samples of designs which, samples of general arrangement, which is GA, that was done on AutoCAD. So if I click on this polyline, you can see it's under the layer called column. If I click on this grid line, the center line, it's actually on the called grid. Okay, let me suggest maybe I should do a recording for you, record it and then send to you on Telegram. Then if you have a challenge, you let me know. We'll come live online and then we trash it out together. Then you can show me your screen and then I can guide you properly when you are stuck at any level. I don't know, maybe we should work that way. Because the challenge now is the network. Will recording work for you proper? All right. Okay, without importing from AutoCAD. Direct from the software without importing from AutoCAD. Is that what you're saying? Okay. Of course, it is. It is. It is very possible. It's very possible. Yeah, it is. It is possible. But are you seeing my screen? Are you seeing the screen? To do that is actually very easy. Just to click on new project. We choose a code of practice. Sorry, I have to give it a name. New project 1. I'll just add 1 to that. Okay. The first thing you do is your axis. Your axis is actually the first thing you have to actually place. So you come down to your modeling here, your modeling tab. Okay. You can see we have the orthogonal axis generator. Then we have the grid. This is actually a single one. This is a multiple one. So with this, you can place multiple axes at a time, where you have lines that cut across each other. Okay, along the x and y. So if I click on the orthogonal axis generator and I click anywhere around the window. Sorry, that didn't work. You double click and then you click the window. Okay, so you can see orthogonal axis generator. Here you have the axis spacing, 5,000 by 300. It's telling you that this is 5,000 millimeter, which is 5 meters, in 3 places. That is actually what this means. So you're going to have 3 axes at 3 meters, at 5 meters interval. Do you understand? Along x axis. Then along your y axis, you are going to have 5,000 millimeter spacing. You are going to have 3 axes, space 5,000 millimeter. Okay, that is 5 meter spacing in between them. So if that is correct, if I click on OK, so sorry, you can play around with that. You must not work with the default spacing is giving you there. You can play around with it. So you have from here to here, you have 5 meters. From here to here, you have 5 meters. From here to here, you have 5 meters in 3 places. So the span, you have 3 spans. That is exactly what that means. Here you also have 3 span, 1, 2, 3. But you have 4 axes along the horizontal. Then you have 4 axes along the vertical. So automatically it gives you the grid number 11223344. So here it comes AA, BB, CC, DD. So that is exactly the first thing you do. Okay. What if this from here to here, let's say you don't want this axis to be up to 5 meters. You can just click on that axis. you right click, you can actually offset this axis. You can move the axis. So let's say we want to move this. I click on move. If I take my cursor up, you can see it's following, but you have to hold on control, then F2. Now, if you are taking it upward direction, is positive. If you are taking it downward direction, is negative. So if I hold on control F2, I will type, let's say, 2 meters. And I click on enter. Now you can see it has moved. Now that means that from here to here, it's now actually 3 meters. How do you know? You can actually measure. All you need to do is just to right click on your mouse, click on measure, tap here, the first one, and tap here. It gives you the measurement. Now you can see the measurement is in 3 meters because I reduced 2 meters away from it, out of it. Now, if that is correct, let's assume our axis is perfectly arranged the way we want it to be. Are you following? All right. You can see here we have column, we have wall, we have beam, we have slab, we have rib slab, we have slab strip. Okay. Now, these are the major structural members on building. Okay. The only thing we don't have here is our footing, okay, which is the foundation. But our slab is here, our wall is here. The wall is when you want to do maybe like a retaining wall, that is a shear wall, or you want to design, let's say, like a lift, okay, that wall there. Then here under here we have the rib. So under your rib you have your waffle slab as well, so you can use it for waffle or your rib slab. Then this slab here that is written slab is for solid slab. And again, you can as well achieve even your flat slab. I'm going to show you that much more later in the training. Okay. So the first structural member here is to place our column. If I click on this column, you can double click on it. Now, this actually pops up for you. As the structural engineer, you can actually choose a column section that you feel is actually going to be safe and is as well going to be economical. But when you choose your sections, while you run your analysis, it will tell you whether the section is sufficient, whether it has passed or it has failed. So in a case where those structural members failed, that is where you most likely maybe want to change the sections. But there are a lot of other options you can actually choose in a case where your structural member fails. Sometimes it could be the reinforcement size that you may change. Sometimes it could be the spacing of the reinforcement that is required to change and all of that. Okay, so coming back to the steel column section, here I'm going to use 230 by 230. Mainly in Nigeria, we use 9 inches block in Nigeria. So the plastering and the block size itself, so it will align with a 230 by 230 mm size of column. So 9 inches is actually around approximately 230 mm. Are you there? Are you following? All right. Here you can see here we have like a dot here telling you the position where you want your column to be. Okay, so it is customary to centralize your column except for aesthetic purpose. But most times we centralize a column in order for it to carry the load properly. So I'll click on this, which is indicating that this column should be placed at the midpoint. So I can place this column one after the other. You can see I just placed one there. You can see 1C1 telling you that this is actually column 1, story 1. So the 1 means column 1, story 2, 1. Okay, so if I place the second one, you're going to see 2 attached to it. Good. You can see now you have 1C2. That means story 1, column 2. Okay, so if I click here, this will be 1C4, this will be 1C3. Okay, so you can make it faster by highlighting here. If you highlight, it will place the columns in those axes properly in their right positions. Okay, now having done that, the next thing you do is to place your beams. So you can see this has actually bring us to our column tab. Okay, automatically by itself, it has bring us to our column tab. So here you can edit the structural, the column member. Okay, you can edit the column member. We are going to go into that much more later in the training. So I'll come back to my modeling tab and then I'll click on beam. But mind you, the software automatically has assumed a 3 meters height for us. Okay, if you click on your view and you right click, sorry, not view, sorry about that. If you click on story and you right click on your story here, you right click, come to edit story. Here you can see by default the height is 3 meters. That's the height of this building is 3 meters. So you can change the height of the story to suit the architectural drawing. So but in Nigeria the standard height of building is mostly around 3 meters. So 3 meters is more like the customary height, except when you are designing like a warehouse or you are designing like a workshop or like a church or a mosque. But in residential building, it actually falls within 3 meters. So I'm going to leave it at that height. But you can see the foundation depth here is 1,100. So the foundation depth too is determined by maybe by the number of the stories that you are actually going to design. So the stories will determine how deep your foundation will actually go, and then sometimes it could be the soil property. So there are so many factors that may affect the foundation depth. So we are not actually going to that for now. Okay. So let's come back to our beam here. So I double click on my beam. So you can see the B, which means the breadth of the beam, the H, which means the depth of the beam. Okay, this H top means where you are actually having how do I explain this? That is, there is a part of the beam that will actually shoot out of the slab. That is where you have this H top. But you know, this slab is actually going to align with the top of the beam. So it's going to be a 450. Sorry, I didn't get you. Exactly, upstand beam. Exactly, upstand beam. Yeah, the technical word, I lost it in my head. I was just trying to remember it there. Exactly. I forgot it. That's exactly what I was trying to say. Yes, yeah. So the breadth of the beam is going to be 230. I want it to align with the block line too. So it's going to be 230. The H450, most especially when you are going for a span. Sorry, I'm not teaching you structures. You are an engineer already, so so so. Oh, okay. So, oh, oh, okay. I thought you are an engineer. Okay, okay. Okay, so from the length of this axis, you can see it's actually 5 meters. So the depth of beam of 450 is very okay. That depth of beam is okay. But the moment I'm going more than 5 meters, let's say I'm going for 5.5 meters, for example, it is advisable I increase the depth of the beam. Yes, so the span affects the depth of the beam as well. Okay, but 5 meter span is very okay for 450 depth of beam. And again, if it is less than 5 meters, it is advisable you actually use 450. So 450 beam is advisable you adopt that depth of beam. I don't know for your country, but in Nigeria, we adopt that depth. Exactly, you're very correct. You're right. That's right. All right. So I'll drag this and then I drop here. Okay. And then as for this, you can use escape in order to free that. And then I drag here, I drop, I escape. Escape once, okay? I drag, I drop, I escape. and then I drag here, and then I drop. Okay, for this I'll do the same thing. I drag and I drop. Here also I'll drag and drop. I escape. I drag here, I drop, and I escape. I drop, and then I escape. Sorry, I'm not going to take you very far today on this training in order for you to be able to digest what I have done. So I'm not going to go very, very far on this because it may look very simple, but the moment you start trying it on your own, you may have some confusion. So it's advisable I don't go very far on it. But the software is very, very easy to work with. Sorry, I didn't get that. Oh, okay. Okay, I get you. It's all right. Yeah, I may be able to spare up to maybe 30 minutes from now as well. Yeah. Okay. You can see here now. We are on plan view. Thank God you are actually very much inclined with architectural drawing. So I can switch this to my 3D, but okay, let me just click on view here. I'll right click. I'll click on 3D physical model. It's going to give me the 3D part by the side. So I can switch in between. So you can see this is the 3D. I can switch to the plan view. Yeah, but I love to work on two windows at the same time. So I will like share the screen. So if I come to view tab here and I click on tile vertical, okay, I can make it horizontal. That means one will be up, one will be down. But I prefer to work with this. And then you can make it as many views that you want to have at the same time. But I love to work with just two. So I have my 3D view here. I have my plan view here. So as I'm working in real time, you see the 3D reflecting. Okay. Okay, Amuchu. Is it possible to do what? Delete the grid? You mean to delete them? Nah, if you take it down to no. This is for first floor. If you want to, once you delete, you move this now, that means you are moving the structural member on that floor. Yes. If you switch to story, this down you are seeing is actually story 0. It's starting from 0 here, you move, this is 3 meters. Look at story 1. This is story 1, 3 meters. That is why the grids are on at the top here. If you go to story 0, you have your grid there too as well. So it has no, you can't even delete them. Any grid, you have to delete the structural members that go after that axis.
I understand what you're saying. Yes, I understand.
No. You can't put them below the column. It's not. You can't put them. Yes. All right. The next thing here is to add the wall load. So I'm going to click on one span of this beam, and then I will right click, and then I will come to edit wall load. So I'll add the thickness of this wall is 0.23, which is this is in meters, so that is why I'm changing the value to 0.23. Okay. This is by default here. It's just to divide 230 divided by 1000. It gives you 0.23. No, this is by default. You can either change it to metric unit, or you are changing it to what they call this. Is it American standard of measurement, that is in inches and feet and inches and all of that. So it's not confusing. It's just to add is a 0 to it. It's going to be decimal. Yeah. Wall unit weights. So this is the unit weight of your wall. Civil it's not just modeling. You need to get a design book for structural design in order to have an insight of what this is all about. Because the unit weight of wall in British standard, we use 2.87. Okay, that is the unit weight of the wall. And then the wall height we are using on our design is 3 meters. So this is not something I can just explain in a video like this. You need to make some little research on this in order for you to understand where this is coming from. I can recommend a book for you, but I'm not sure you can get the photo, the soft copy, the hard copy in South Africa. I'm not sure if you can get it there. Are you there? Yeah, I'm not sure if you get it in your country, but there are other books I can recommend. There is Mosley and Bongi. There is RCD. Simplified reinforced concrete design book by Victor Oyenuga. Yeah, don't worry. I will write down the list of the books on WhatsApp so that you can research on them. Maybe you get the soft copy on your phone or on your PC, and then you can study them in order to have an insight. Okay, these walls now here, you can actually add what we call opening on those walls. Okay, so you can create an opening on the walls, because you're not just going to have walls all through. There are places you have windows, you definitely going to have openings. You have doors, you have windows, okay? So you have to create an opening on each of the wall. So you can follow the architectural drawing there. Wherever you have an opening, you place it there on your design. So you click on that opening, you click on add. So you can see here it is placing our opening at this middle of this wall. The wall length is 5 meters. The wall height here is 3 meters. And then here you can actually change the width here. You can see W, you can see H, which is the height. And then the X, Y is telling you the direction which we have moved this to. So you can change the size of the wall. Let's say this wall is 1,200 width, and then the height is 1,200. Let's see what we have. Now you can see the wall opening has actually increased. So if I click on OK, and then I click on OK here. Now, if you notice, you discover that that value has actually even dropped, because the first value that we were getting there was around 8 point something. But when I created an opening, it reduced. So thank God you are recording this. You go through it again, and so that you go through what I was having there, in order for you to have a better insight of what I'm talking about. So if you look at this very well, you discover that an opening has been created on this wall. I believe you are seeing the wall I'm talking about. Okay, the wall is on this beam. So what I'm going to do now is to copy the wall load. Sorry, I think this is still loading or something. So I just clicked on the wall. Click on the wall. I'll right click. I click on copy wall load. I'll come to my building, come to my modeling. I'll come to filter. Okay. If I click on filter, I'm going to deselect everything. I'll select my beams, and then I can highlight my beam from my 3D view. So you discover that only the beams were highlighted. Sorry, I'll take that again. Now you can see that only beams are highlighted. What is wrong? Something is wrong. Okay, so I'll paste copied beam load. Okay, and I click on yes. And I click on yes. So mind you, this wall load, their openings are actually not the same everywhere. There are places where you are going to have a door, not a window. There are places where you're going to have just an opening. Maybe the size of the opening is actually not the same size with the one you have here. So it actually varies based on what you have on your architectural drawing. Okay. Are you there? Okay, good. So let's say I want to edit this wall, edit wall load. let's say here, what I have here is a door. Sorry, please, this is just me trying to explain how to make use of this software. So I'm not saying there's going to be a door there. So you just follow what you have in the architectural drawing. Okay. Now here you can see from here to here is 1 meter, right? So this Y here, I'm going to make it 0 because I want this to drop down to this point. And then this H, I'm going to make it 2,100. This is actually the normal standard height of door when you are dealing with residential building in Nigeria that we normally use. So I leave it at 1,200 and I click on OK. So you can see that this opening here has actually changed. Okay, so you can do that for all that you actually want to achieve in your design. So let's say I want to generate all of this structural member to the next story, because this is actually going to be a story building. So I'll generate all of this. Let's say all of these are I'm looking for generates member. Okay, I highlight this. Right click. Okay, highlight from right to left. I think it's better than left to right. Something is wrong somewhere. I don't know. Okay, it seems like I'm on story 0. That's what I'm seeing here. Story 0 is for foundation, okay? Yeah, it's for foundation. So I'm not supposed to do my model on story 0. So I'll switch back to story 1. I made a mistake somewhere. Okay, exactly. It's now appearing the way I want it to look like. Okay. Perfect. Now I'm going to highlight this, and then I'll generate members to other stories. So, but sorry, I did not insert the number of stories I want on this. So I have to insert the number of stories because I only have story 1 here. So what I'll do now is to click on stories here, and then I'll right click and I'll insert story. So I'm going to type 2, and then I'll click on OK, and I'll click on yes. So I'll go back to story 1. So here now I will highlight this. I'll generate member to other stories. So I'll click on 2, and then I'll click on OK. Good. But you can see from the 3D here, I have a wall here at the top of this beam, and I don't want that. So I can manually delete this by just selecting and clicking on delete, or I can highlight all of this, and then I'll right click and I'll delete wall load and I'll click on yes. So now you can see by just okay, it's still loading. Okay, it's still okay, it's done. But you can see one beam here is actually missing, so I can add that beam back. Sorry, I'm just going to add a beam here. So I'm going to add a beam here, and okay, so here let's say 230 by 450, but you know, this is a roof beam, so I'm not going to use the depth of 450. It's too much for a roof beam, so I'm going to change that. I'll show you a faster way of editing all of the beams. So we are going to edit it faster. Okay, so here from my filter here, I will deselect all. I'll select beam, only beam. So if I highlight, all my beams on this story is going to be highlighted. So I'll right click on it and I'll go to properties. Okay, so here, if I drag this here, you can see here I have bottom, all of them here are 450. So I'm going to click here at this point here. If I click, all of them are highlighted. I'll now click on this column wise edit. So if I click on that, I'll type 300 because this is actually a roof beam. So I want it to be 300. So all of this is going to change to 300. Okay, good. Now I'll close this. Now, if I zoom this, you can see my beam at this level are all 230 by 300. So all my beams at this level are 230 by 300. So I will exit. So I'll go now to my story one, because you can see I only have two walls here. I want to have my walls around all of them. So I will select, so I'll go to story one. I'll select this one that has wall. I'll right click and then I'm going to copy wall load, and then I'm going to highlight my beam. So, and then I'll right click, I'll paste copy beam wall load, and I'll click on yes, and I'll click on yes. Okay, good. Now, if you view it from the 3D, you discover that we now have openings on all of that wall, Now all my walls have been pasted on all of along my beams, okay? But this may actually not be correct because we are definitely not going to have windows everywhere as it is like this. So like I said, you can play around with it, okay? You can remove even the opening if you don't want, where there are no opening at all you need to do is just to click on that wall, right click on edit wall, and then you can remove that opening. Just come to edit opening, and then here I'll make here 0, and then here, okay, sorry. Yeah, so you can just click on delete and you have deleted the opening, as simple as that. Sorry. So I just deleted that opening. So let me repeat this process again. I'll click on this wall, I'll right click, and I'll come to edit wall, and I'll click on edit opening, and I'll click on that delete, and I click on yes, and that is all. So wherever there are no opening, you can delete the opening. So just work with the architectural drawing. If you have the 3D of the architecture, you can actually just place all the right opening in their right positions. But to save you much time, what I usually do is I don't even include opening. I will just make it. I do my design on worst case, and I run it, okay, without an opening. Okay, but if you have much time on your design, you can place all the openings in their right position. I don't think it has much effect on it. So if you don't include the opening, it tends to add more load to the beam. But I believe the load that is added is actually not that much that it will affect the building that much. So uh, it tends to give you a more safer result, and then it's actually not going to make it more it's actually not going to make it a lot that expensive. Okay, all right, I'll select all of my filter here. You can see my filter. Only my beam is, I can only select beam using this filter. So I'll select all now. I can now select all my structural members. So you can see everything now is actually in its right position. What we need to include here now is our slab and also our foundation. But our foundation is actually going to be lasting. That's after analyzing the structure, then we include our foundation. So I will switch to story 1, which is this. You can see by the left hand corner of my screen. So if I zoom here now, I'm going to insert my slab. So let me be sure of the level that I am right now. Okay, so I'm in story 1. So I'll just double click on my slab. I hope you're following, sir. Okay, I thought you are sleeping already. Okay. Okay, good. All right, good. Okay, no problem. Yeah, exactly. Okay, so in few minutes remaining, I'm going to insert my slab very quick. You can see the height here, 150. It's customary to use that thickness, most especially when the span is not that much. So you can use 150 thickness of slab, but if it is not safe, it will tell you that the deflection is actually not okay. If the software will tell you if the deflection is okay or not. But I always like to start with 150. It's more economical. And then the concrete cover, I like to use 20. We have different concrete cover depending on the structural member that you are designing, okay? For beam, for slab, for column. So the structural member will determine the thickness of the cover that you are actually going to specify. Okay, so here now I'm going to insert this slab here. I will insert another here. I'm going to make it just very fast because of time. Sorry for this. Let me just edit this. For your slab, I'll come to my load, and then I'll come to my dead load. This dead load is actually a calculated value. Is gotten from when you multiply the density of your concrete. It's usually 24 multiplied by the thickness of the slab. Sorry, when you actually lay your hands on those books I'm going to recommend to you, it will give you a deeper insight of what I'm talking about, since you're actually not a civil engineer. If you were a civil engineer, I wouldn't have been going into this at all. So that will give you an insight of what I'm talking about. So I'm going to use a value of 5.8. Okay, and then I'm going to, on my impost load, this building, I'm assuming this building to be a residential building. Let's say I'm designing a residential building, maybe like a 3-bedroom, like a 4-bedroom duplex or something. So I'm assuming this to be a duplex, a building, okay, a residential building. So that is why I right click here and I choose residential building. And then for residential building, the value is 1.5. You can see the value is reducing and it's increasing, and depending on the class of building. So if you are designing a shopping area, is 4. If you are designing a plant room, is 7.5. So it changes depending on the kind of building, the class of building, okay? Yeah. So here I'm going to update this for this. So I just update that. And then there is another thing here, the slab type. Okay, this is another thing you need to know. The cases, the edge conditions. We have what we call edge conditions. We have, as for this slab, it's actually going to be 2 adjacent edges that are discontinuous. I know this is a very big grammar that you might not have heard of this, but then you can see here number 4 actually looks much like what we are going to have here, based on what I just stated. You can see here what that means is that this side of this slab and this side of this slab is not continuing anywhere. Okay, it's facing outside. Let me just use the layman language. It's facing here, is after this is just outside, after here is outside, but here you're going inside, here is also going inside. So that what that means is that there's going to be a slab here, there's going to be a slab at this position too. We also call this continuous, but at this point
We call this discontinuous. At this point, we also call this discontinuous. So what that means is that we have 2 adjacent edges that are discontinuous, and we have 2 adjacent edges that are continuous. So that is what that means. So I'm not going to go into much of that right now, because today is more like we are introducing this software. So I'm just going to place every other slab
in their position. Okay, okay, okay. Exactly. Yes, exactly. Okay. Yeah, that's right. So we are going to have, based on these conditions, there are some that are going to be internal slab. We are going to have external slab, cantilever, and all of that. So based on these conditions here, okay, because you're going to see this number 9 is indicating that the slab is an internal slab, okay. So it does not no, sorry, that's not correct. This one is indicating that this slab is discontinuous everywhere. So this is a bit tricky, but once you understand it, I don't think you're going to have any issues. This is indicating that this is an internal slab, so that there is no, it continues at everywhere, okay. So but I don't think in this design we are going to have any slab that is going to be completely internal, because around here we are going to have, let's assume there's a staircase here. So around this staircase area here, this slab is not continuing, okay. So we don't have any slab here that is completely internal, okay. So all of them are discontinuing in one way or the other. All right. So let's assume we place that in their right positions, because that is actually going to take a very long time to place all those slabs in their positions. But it's actually not difficult to achieve. Once you get the theory behind that, that's all. Okay. After achieving this, um, let's come to analysis. Yeah, you said? Okay, okay. Analysis is your favorite part. Okay, interesting. Yeah. So this analysis, I'll click on building analysis. So we are done with the modeling. We are assuming that our modeling is 100% the way we want it to be like. So I'll come to edit. Yes, roof slab. No, no, no. If you want to have a roof slab, you have to include your roof slab. But this is not going to have a roof slab. That is why I did not include a roof slab. Yes, I'm assuming this to have roof trusses, like the normal wooden roof trusses, not roof, not slab. Do you get it? Ah, are you there? Okay. So I edit materials. We have columns, walls, beams, slab, ribs, links, and then this is for steel column, steel, anything that has to do with steel. But while this from here to here is for reinforced concrete. Okay, so for column, we have what we call characteristic strength of concrete, not just for column, for every concrete. Every concrete material, it has the characteristic strength. Okay, that strength is actually determined in the lab. Okay, is actually based on your mix ratio of your concrete. So I'm going to be using grade 2025. So as you can see, all of them are already carrying that grade, but you can actually just click on it and change to whatever grade of concrete you want to use. But I usually use 2025. Okay, and then there's what we call characteristic strength of steel. That is actually the strength of the steel. It is determined also in the lab. Okay, when you go to structure lab, uh, they have a machine that will stretch that steel, okay, until it gets to its breaking point. So there you get the results of what strength is that steel, okay, and that reinforcement. That's what I'm trying to say. So it is gotten from the lab. 410, it's actually a very good grade of steel, which we use for mostly residential buildings and most of the structural designs here. So I'm going to maintain 410 for my steel, and then 20/25 for my concrete. So the column here, I'll click on deselect. I will deselect everything. So in Nigeria, it is customary to use Y16 for column. Sometimes if you select Y12 among the reinforcement, it will most likely do your design providing Y12. The reason why we don't use Y12, I think, based on my opinion, is because most of this reinforcement don't come in their actual size. When you use a vernier caliper to check the size of that reinforcement, for example, for Y16, it's actually usually not up to that 16 mm. So